We'll go to this sum. This is Jan 2020. I'm taking question 13 for discussion. State what is meant by center of gravity. Center of gravity is the point where the total weight of the object is appear to be acting. Easy marks. Point where the total weight of the object is appear to be acting. Go to the next part. They are telling there are contact forces at the two positions where the book touches the shelf. That's in this point and that point. There are two contact forces. Book is moved a distance x to the right. It's moved to the right. Okay, the magnitude of the contact force R varies with x. Sketch on the axis below the variation of R with x between O and L over 2. You should mark the maximum value of R on the x-axis. So what are we doing? We'll be moving. Starting point will be somewhere here, no? When x is equal to 0. Then this is the second point. We'll take this is the second point. We'll move it forward. Then finally we can move it up to this point. Up to this x is equal to L over 2. X is equal to L over 2. That's in half the book is in that side. Half the book is in that side. Then on it will want properly. I'll take this like this. Try to check it diagram. From what you see, like this, which shelf is there. We'll be moving it. We can move this until half of that. So at that time, at this edge, the center of gravity is aligned. After that, it will topple over. After that, it will topple over. Okay. So now variation of there's a contact force here, then there's another contact force there. That's what we are talking about. I'll show the other contact force. There's another contact force here. There's another contact force there. There's some other value. Then how the contact force varies. So we'll keep into these positions and we'll try to get the values. 0 means I have to keep it. We'll cover this one. We'll do the new column. Initially, I'll be keeping it like this. Okay. At that edge. Will be here. The slant, I don't know, so say two contact points should be there. Okay. Now got it. Two contact forces are there. There's one contact force here, R dash. We are not interested in R dash. Then there's another contact force, R. Weight is acting in the middle. Okay. There are two ways I can get R. One way is the normal will take moments. This is a difficult way, but I'll tell you easy way for this. Now this is L over 2. That full length is L. So if I take moment about this point A, if I take moment about that point A, total clockwise moment is equal to total anti-clockwise moment. Total clockwise moment is equal to anti-clockwise moment. So the total clockwise moment is made by W. W is making the total clockwise moment. So that is W into L over 2, no? W into L over 2. Anti-clockwise moment is made by R. Anti-clockwise moment is made by R. Okay, it's like this, same like that. So I'm taking from this side. This is W over 2 R. So it will be R into L. R dash can't make any moment. The reason for that is It's on A. There is no distance from that. Okay, L cancel off. R is equal to W2. So X equals 0, R is equal to W2. I'll mark a W here. R will be equal to W2. I got 1 point. They're asking this point and the maximum point, but there's a hint there. I have to get the LO2 point that way. So the maximum point means I'll move it to the edge. I'll move it up to the edge. This is the maximum point. Again, I'll cover this. I'll cover this. Then I'll try to move this up to the edge mean halfway. This is the maximum. Earlier when I forgot to tell you the easier one. I'll do it now, otherwise I'll forget. Earlier situation, if you observe it, can you see it was there like this now? So weight is acting exactly in the middle. The shortcut is, if you think carefully, by symmetry, these two R's should be equal. Those two R's should be equal by symmetry, because it was a symmetrical situation earlier, not now, earlier. Therefore, the easier way to get the answer is 2R is equal to W. If I say 2R is upward forces equal downward force, total upward forces equal total downward force, WR. That way is easy. R is equal to W2. As most students might not see it like that. That's why I did it like that earlier. But that's the small class way. If you have a plan, in the middle something is there, lorry is there in the middle, a bridge is there, then R balance, 2R is equal to W. Small castings also work in this level. Okay, now I had moved it halfway there. This is R. This will be R dash. This will be W. The distance will be L over 2. Again, I'll take the moment from this same point, A. This is the moment wave. The wave also there, we will come to that. DC wave also there. Clockwise moment is equal to anti-clockwise moment. So what do I get? Clockwise moment is made by W. W into L over 2. R also same distance. R anti-clockwise. R into L over 2. L over 2, L over 2 cancel off W. Okay. Then, no, this might be your mistake. Don't be in a hurry and try to connect this in a straight line. So examiner gave a L over 4. So take that also. It's actually not a linear relationship. Later I'll show you that. So he has given a L over 4 there. This might not be a linear relationship. Okay. Then we'll do the calculation for that. So this one, the easier way is like this. It's at the edge, no, at the edge, if it is balancing, it's balancing on the center of gravity. So when it's balancing on the center of gravity, normally the contact force pass from there. So that R will be straight away equal to what? W. It start losing the contact from this side. R dash will become 0. This is called tilting. Tilting about that point. Okay, another term we use. The object will go there, start tilting about that point. So that's why R dash will become 0. It's balanced there at the center of mass. If you know that, it will tilt. Tilting means lose contact from this side. Can you see? When it moves to the middle, it lose contact from this side. It's tilting. R dash is 0. So R is straight away equal to W. That's easy. So the examiner is not asking any method here. He is asking you to sketch the graph and no working. The values are straight away marked. I give the mark. But if you are not sure, only you have to show the working. Now you are not sure whether he's checking the working or not. In a corner, show the working. But this some No marks are given for the working. Now we'll calculate for LO4 situation. LO4 situation. We'll draw it for LO4, but we'll cover this one. L over 4 is outside. That's mean 3 over 4L is inside. No, 3 over 4L is inside. So we'll do that situation. So still the weight is in here. Weight is here. W is there. R is there. R dash is there. Again, I'm taking moments. R dash is there. About this point here, I'm taking moment. About this point A. So what are distances? This is L over 2. This will be quart is outside, so 3 quart is inside. That's 3 over 4 L. So about A, weight is doing the clockwise momentum as usual. Cross moment should be equal to anti-clockwise moment. Should be equal to anti-clockwise moment. So that clockwise moment is L over 2 into W. Other one is anti-clockwise is 3 over 4 L into R. L cancel off. This will become R will become 4 over 6. 4 over 6 mean 2/3. 2/3. So 2/3 mean this one I have divided in 3 parts, 3 per sections. If you get a scale, it will be easier for you. Approximately sketch. I divided this W into 3 pieces. And here it will be 2/3 of that. Okay. So now you will see when I see when I double length, it became double when quad. Now this one to this one is double. So it's not obeying a linear relationship. Oh, you can see that. The reason now this value is then this length value is then if it's a linear length, linear relationship, when I double the length, R should be double. So if I double this, I must get 4 over 3W. No? But I got 1W there. No? So this is not a linear relationship. It's a curve. Join with a curve. That's how we see. Oh, if you're really good in maths, there's another way of seeing it. You see those who are really good in maths, we'll write the equation for this situation. Then they start seeing everything. No? R dash. R dash here. Then weight is acting there. This is for students who are really, really good in maths. Huh? Earlier ways, normal students, normal students who are okay with maths. Of course, if you do physics, you must know your maths. L over 2 here. Then what is this distance? L minus x. So if I take the moments from here, clockwise moment should be equal to anti-clockwise moment. So as usual, like earlier, W into L over 2 is equal to R, where R dash can't make any moment, R into L minus W, x, L minus x. Can you see these two? Now, if you want to get the values now, since we have the equation, if you can derive this equation, one shot you can get all the values. Now, when I put in the place of x, When I put L, first part is L, no, I am moving the block there fully. The block is fully inside, so X is 0. So block is fully inside, X will be 0. So when X equals 0, I can say R into L is equal to W L over 2. L cancel off, R is W over 2. Okay. So R is W over 2. We'll take the last point. When I move it half a length there, X is equal to L over 2. X is equal to L over 2. When I put X is equal to L over 2, now I'm moving L over 2 there. So this is R, L minus L over 2. L minus L over 2 is L over 2, no? Apple minus half apple, L over 2. Apple minus half apple, half apple. Apple minus half apple, half apple. L minus L over 2 is L over 2. Cancel of W. Getting that. Then, that's W. Then I'll put L over 4 here. I'll put L over 4. If I put L over 4 here, L minus L over 4. And cake, someone is eating part of the cake. 3/4 will be remaining. 3/4 of a cake. Again, same answer. But all three answers came. But now, this is what I said. If you're good in maths, you must identify this as a negative series of variables. Now, these are two variables. Now, R and X are going to get multiplied. R is Y axis. Y and X getting multiplied, and this is a constant. W is a constant. Length of the book is a constant. Therefore, two variable minus multiplied is a constant. We call it like this. Yx is equal to, we say something like 2. This is also not this. This is called a reciprocal function. In other words, y is equal to 2 over x. Those who are doing P1 know this. 2 over x. This is the reciprocal function. But this is minus x is there. So that is minus y over x is equal to 2. Negative reciprocal function in P1. Those who are doing further maths, this is called a rectangular parabola. Okay? Same Edexcel, same syllabus, but in P1 we call it reciprocal function. But when you come to FP2, we'll be calling it rectangular parabola. Okay? Y is equal to minus 2 x. What does this look like? It will actually look like this. It will go from here and here. But I'm adding L now. When you add L, all the x coordinate you have to, it's a shift. So all the x coordinate will move forward. All the x coordinates will move forward by L amount. So when this move forward by L amount, what does this curve look like? It will go, what you see is this way. You see, it will move that way. Then see this, so the curve will move there. It's a curve. But what I said is non-math student, you must see the relationship here. At this point, it became 2/3. No? At this point, it became 2/3. 2/3 W. 2/3 W. You don't have to think this much. Those who are maths, those who level of maths is there. If you are further maths students only, you might be good in this. But even P1, no? P1, if you're really good in P1, you'll identify this negative reciprocal function. But for others, if you're not doing maths, don't worry about it. You know the basics, no? This is L over 4. L over 4, if I got 2/3 W, if I double that length, if it's a linear relationship, if I double that length, I must get 4 over 3 W. I did not get that, no? Therefore, this is not a linear relationship. Therefore, I am not going to join this with a straight line. That's what you have to think. The next part, this is something usual. Sometimes you see this in oral papers also. I refer to a oral paper sum. This is oral paper sum. They say, you might have done all your last year, so you might remember this if you have done a lot of past papers. There's one more paper now. There's students sitting on a chair. The fellow is rocking the chair. Typical students. Rocking the chair like that. So when the center of mass is here the weight is acting there. The fellow is rocking the chair. Oh, let me. Fellow is rocking the chair. Now what will happen? Weight will go out of the base of the object. Can you see? That the normal contact force, we normally see. Now this is the point where here the normal contact force can act and here and here there. We'll take this base, this is called the base of the object. So since the normal contact force act there, there's a clockwise moment and anti-clockwise moment. Both can get balanced. But here, now R can't do anything. Why? R can't make any moments. The center of mass is leaving the base of the object. So in this case, center of mass is leaving the shelf edge, the joint of the shelf. Therefore, total clockwise moment, there will be greater clockwise moment. Because on the point here, examiner is not referring to that. It's actually on the point I told you something happened. No, at that point, what will happen? It will lose the contact here. So there is no contact force there. So only contact force is there. So if I move it further than that, that fellow also can't balance it. Did you get, now if you come to this point, the tilting point, R is somehow balancing, R is balancing W. This fellow will become zero. That R dash will become zero, other contact points. Okay. For this exam, you don't have to tell that much. Okay. But it's better detailed answer. You must tell. Go back to the question and I'll show it to you. This point, at this point, what will happen? R is balancing the W. Okay, that's so far so good. Now, we'll take the next point. Center of mass is going out. So at first still, center of mass is going off the shelf. There is a total clockwise moment. So R can't make moments. The reason is what? Now it's pivoted on R. It's turning on R. It's pivoted on R. That was not there, I think, in this mass scheme. Check it. That this. But tell the full story. If you want, you can tell more. It will lose contact at the other point. R dash becomes zero. If you have notations, you can say R dash becomes zero earlier. Working if you had notation. There's too much this part, but you will write like that. R dash becomes zero. R can't make moment. The reason is it's pivoted on R. So pivot is on R. Weight is going off the shell. Weight is going off the shell. There's a total clockwise moment. But for how if you just say weight is going off the base or off the shelf is better. Okay, off the base also fine. Weight is going off the shelf. Weight, center of gravity is going off the shelf. Center of gravity is going off the shelf. Weight is acting off the shelf. There's a total clockwise moment. R can't balance, R can't make moment because it's pivoted on R. Therefore, it will topple over. Okay. Okay. But if this is not clear, next time when you meet, ask.